Hi. I would like to better explain what is rapid motion and shading rate all about. So to better illustrate this functionality, I'm going to build a very simple scene, but very effective to actually demonstrate the capabilities of this new shading rates and rapid motion. So I'm going to create here a simple grid, mesh grid, on which I'll be putting a XZ projection and use a constant material because I don't want to have any shading whatsoever and simply use a complex and dense texture noise shader. So if I render this right there, you'll see that obviously it renders with some lower quality. In this case, what I want to use is go under render option and triggers or enable the actual rapid motion technique. Let's go under optimization, turn off ray tracing, set the scanline mode to rapid motion for very large scene. Okay, as you can see now, it's starting to create these triangles. So let me explain what these triangles are all about. One of the scanline is basically using an adaptive sampling where it breaks up the pixel to be able to get the details inside the pixel. Whereas scanline is a little bit more like different. Instead of actually sampling the triangle, it's going to create finer triangles. And these triangles are virtually non-existing. They are just created at render time, and they represent the actual surface. So the idea is to create these triangles as small as possible, so they fit actually inside a pixel. So even before talking about shading rates, I'm going to set the shading rate to 1, and I'm going to get the actual sampling here -5, -3. So what this thing is doing is quite simple. Is that it will actually -5 is actually something like 128, I think 128 or 256 pixel wide triangle. So a triangle the actual tessellation can actually fit within 256 pixel. And it can go up to -3, which is pretty much 64 pixels wide. Because actually, what it is doing, instead of actually rendering inside the triangles, it's tessellating the actual surface according to the actual texture details. So if I start to increase the actual threshold here, I'll start to pick up some of the details here that is present in the texture. As you can see now, I'm starting to tessellating this thing into finer triangles. Obviously, this is really fast and also very poor quality. I could start to increase the actual anti-aliasing min and max. So again, if I go back to 1.1, which is the threshold is very high, very poor quality. So I'm going to lower it again and start to pick up the details as I see. As you can see, because the actual min-max are greater now, I'm starting to pick up and create much finer triangles that and those triangles will eventually be as small as a pixel. So now you can see now I'm generating triangles. So as I move away, obviously the actual tessellation is going to be adaptive. So if I'm really far away, it's going to generate less triangles. When I'm really, really near, it's going to generate more triangles needed to be able to render this. So this is pretty much a view-dependent tessellation that is done on a per-tile basis. So it's very efficient and it's very scalable technique, especially when rendering very large scene. So I'm going to start to increase the actual max level. So now as you can see now I'm starting to pick up more details, but obviously the actual triangles is actually larger than a pixel. So we see these lines and these tessellation. The idea is really to keep these value above 0 to be able to say, okay, now I want really to have one triangle per pixel. So pretty much if I set 0 to 0, a min and max here, the threshold has basically no usage because I'm just saying, I'm just telling the system, okay, don't even bother, just create one triangle per pixel for this geometry. So even though it's very fine, it's going to render pretty quickly. Actually, these triangles are virtually just existing during the tile rendering. Now if I'm starting to increase these values, as you can see, I don't see any visual differences because it's going to actually create now from zero up to 4 triangle a pixel. So this is pretty much the same thing as anti-aliasing, where a 0 is creating 1 triangle per pixel, 1 is creating up to 4 triangle per pixel, and then 2 it's basically 16 triangle per pixel, and then if we go to 3 it's 64. Now let's say, for example, a pixel contains up to 64 triangles for a given geometry. The shading rates is telling basically how many of these triangles I'm going to use to build up the final pixel value. So in this case, the shading rates picks up more. So let's call it micro triangles to create this pixel. If I start to put it to 2, then I'll start to pick up more triangles inside the pixel, and that will improve the actual rendering. So some of the settings it's really important to see is that do you really see a visual differences when you make a changes? If you don't see a visual differences, seems it clearly shows that this new value will not add to the final image. So as you get closer, obviously you'll get a perfect render. If you go really far, then obviously it will tessellate very fine, but still render pretty quickly. Obviously, if I put that to 0, now I'm starting to have a little bit less quality. I could actually put that to shading 10. Okay, I'm starting to see some changes here. That's great. Okay, if I put it back to 2, you see that the actual differences between 2 and 10 is not that much. The reason is simple, is that even though I put it to 10, the actual triangle or the pixel does not contain enough triangle to be able to go to the maximum shading rate. So that's really important, that even though you provide this, you put the shading rate really high, if the minimum and maximum level are 0, 1, for example, then obviously it's not going to do any good. It won't slow down the render. It will basically just say how many triangles you have in your pixel. Well, it turns out I have 4. Well, I need 10, but actually in this case I'm just going to use all of you, like all the 4 triangles. So that is much. So if I do increase this up to 64 and increase the shading rates, now as you can see, now it's spending a little bit more time to gather all these triangles. Obviously here this is an adaptive tessellation that's going to be done. So it could go from 1 triangle per pixel up to 64 triangle per pixel. And this threshold basically determines how fine the adaptive tessellation is going to occur. So if I lower this slightly, then obviously I get a little bit more blurry. The reason is simple, is that now it's starting to get a little bit more like towards 0 because the quality is really, really poor. So as I lower the actual threshold, I'll be going more like towards 3, which means that it's going to generate up to 64 triangles per pixel. So obviously the quality. So that's really important to really balance these two parameters, which is first pass tessellation, and shading rates is what also we call sample collect. So the number of the actual sample being collected to render the pixel. So I just hope that you'll be using shading rate. And remember, shading rate was designed to render very large scene with a lot of triangles in the scene, whereas scanline has been designed for speed, where speed has always a cost. It always uses more memory, where rapid motion is a more scalable solution. So depending on the type of scene you'll be rendering, you'll be getting different results. So it is possible that sometimes scanline won't even be able to render the scene, where if you switch to rapid motion, well, it will render the scene much slower, but it will render it and it will finish the frame. So there's really a trade-off that you have to pick when selecting between rapid motion and scanline. Thank you.